Pydantic AI's prepare tools. Hook serves as the primary mechanism for dynamically filtering or modifying the list of function tool definitions sent to a model on each step. And this artifact demonstrates that mechanism applied at the agent level to conditionally set strict equals true on every tool definition when the underlying model system attribute indicates an OpenAI provider. The pattern centers on an async tools prepare func that receives a RunContext and a list of tool definition objects, inspects ctx.model.system, and returns either the original list or a new list where each tool definition has been replaced with strict equals true via dataclasses.replace. The code sets up a test model instance, registers a single echo tool using the @agent tool plane decorator, and passes the turn on strict if OpenAI function as the prepare tools argument to the agent constructor, after which two synchronous runs verify that the strict flag on the first tool definition remains none by default and becomes true once the test model's system attribute is changed to OpenAI. From data classes, import replace. From Pydantic AI import agent, RunContext, tool definition. From Pydantic AI models, test import test model. Async def turn on strict if OpenAI. ctx, RunContext none tool defs, list tool definition. List tool definition, none. If ctx, model, system equals OpenAI. Return replace tool def, strict equals true for tool def in tool defs. Return tool defs. Test model equals test model. Agent equals agentist model. Prepare tools equals turn on strict if OpenAI. @agent tool plane. Def echo message, SDR. Return message. Agent run sync to sting. Assert test model, last model request parameters. Function tools 0, strict is none. Hash set the system attribute of the test model to OpenAI. Test model system equals OpenAI. Agent run sync to sting with OpenAI. Assert test model, last model request parameters. Function tools 0, strict. The code demonstrates the agent-level prepare tools hook being used to conditionally modify all tool definitions based on the underlying model. The hook receives the full list of tool definition objects, and when the model system is OpenAI, applies data classes, replace, to set strict equals true on each tool. This is a conditional environment setup pattern where tool behavior adapts per model without changing individual tool registrations. The mechanism works by inspecting ctx.model.system at each run step, then transforming the tool list in one shot. Using prepare tools at the agent level is simpler than adding a per tool prepare method when the modification applies uniformly across all tools. The trade-off is that you lose granularity. You can't selectively apply the change to only some tools without additional filtering logic. This pattern is useful when different model providers have different strictness requirements for tool schemas. OpenAI enforces stricter parameter validation in some contexts, so toggling strict per model ensures compatibility. The downside is that it couples tool configuration to model identity, which can make testing harder if you swap models frequently. Let's break it down. From data classes, import replace. From Pydantic AI import agent, RunContext, tool definition. Imports replace from data classes for immutable object copying, and agent, RunContext, and tool definition from Pydantic AI for agent orchestration, context passing, and tool schema definition. Async def turn on strict if OpenAI. ctx, RunContext none tool defs, list tool definition. List tool definition, none. If ctx, model, system equals OpenAI. Return replace tool def, strict equals true for tool def in tool defs. Return tool defs. Defines an async function that, when the model provider is OpenAI,
returns a new list of tool definitions with strict mode enabled. Otherwise, returns the original list unchanged.
Test model equals test model. Agent equals agentist model. Prepare tools equals turn on strict if OpenAI.
Instantiates a test model and assigns it to test model. Then constructs an agent using that model, passing turn on strict if OpenAI as the prepare tools hook.
At agent tool plane. Def echo message, SDR. Return message.
Registers a tool named echo that accepts a string message and returns it unchanged. The @agent tool plane decorator marks the function as a callable tool without requiring access to agent context.
Agent run sync to sting.
Invokes the agent synchronously with the prompt testing, blocking until a completed response is returned as a run result.
Assert test model, last model request parameters, function tool 0, strict is none.
Asserts that the first function tool's strict parameter in the most recent model request is none.
Hash set the system attribute of the test model to OpenAI. Test model system equals OpenAI.
Assigns the string OpenAI to the system attribute on the test model object, setting an internal system identifier.
Agent run sync to sting with OpenAI. Assert test model, last model request parameters, function tool 0, strict.
Calls the agent's synchronous run method with the prompt testing with OpenAI, blocking until the response completes. Immediately asserts that the first function tool in the test model's last request parameters has strict enabled. The prepare tools hook is the connective tissue here. It takes the tool list an agent would send to a model and lets you reshape it based on the model identity before that list ever reaches the provider. The turn on strict if OpenAI function is the concrete shape of that hook. It checks ctx.model.system, and when it sees OpenAI, it walks the entire tool list and copies each tool definition with strict equals true using dataclasses.replace. That replacement is what flips the schema validation behavior per model without touching the original tool registrations. The two runs demonstrate the lifecycle. First run, test model has no system set, so the hook returns the raw list unchanged and strict stays none. Second run, after test model system is manually set to OpenAI, the same hook fires, the same tool gets the same replacement, and strict becomes true. The assertions just confirm the state changed at the model request level. The design trade-off is worth restating. Agent-level prepare tools keeps the pattern simple when every tool needs the same treatment, but it sacrifices granularity. If you need strict on only some tools, you're back to per tool prepare methods or extra filtering logic inside the hook. And coupling tool configuration to model identity means swapping models later adds friction. That's the cost of the conditional environment setup pattern the hook enables.
The prepare tools hook that tastes OpenAI in the model and carves strict into every tool.